The discovery of the rings of Uranus is a classic story in astronomy. Classic because in 1977, when this was made, nobody thought that any planets in the solar system except Saturn had any rings, and so discovering rings around Uranus was completely unforeseen. Astronomers were trying to do something else. They were studying the rings, and here's a drawing of what we know the rings to look like today, with Uranus in the center. But what astronomers were trying to do was make a study of an occultation. And an occultation is a situation where you take a telescope, and the term occultation means that some distant object that you're looking at is blocked by some nearby object. And so here's a telescope, great drawing here of a telescope. We're looking at some distant star. We're just going to keep our telescope steadily pointed at that star. The light from the star is going to travel over here. It's going to enter the opening of our telescope. We're going to have some kind of an instrument over here that's going to record that light, and we're going to watch it be occulted. That is, the star's light will be blocked by the planet Uranus. Occulted means if we're looking at that in the sky, we'd see the star and we'd see Uranus next to it, and then Uranus moving along in its orbit will pass right in front of the star. That's what it'll look like. And what we're interested in doing is making a drawing that will show us a graph that will show us as a function of time what the brightness of the star is. So on the vertical axis, we're going to plot brightness, and on the horizontal axis, we're going to plot time. Okay, so time is going to be measured along here, reading to the right. And if we're just looking at the star, and the star is a constant, steady thing that doesn't change much, what we'd see is a rough horizontal line that looks like that and doesn't really change very much. There'd be a little noise in this line because there's always measuring error as we try to measure something that's dim like a star, but it would basically be a horizontal line. So what astronomers were interested in doing, and here's the planet Uranus down here, and Uranus is moving in its orbit, and let's just imagine that it's moving like this, so that it's going to pass between the telescope and the star in just a minute. So it's coming along, it's going to move along like this, and will block the light of the star as it enters the telescope. What astronomers were interested in doing was studying the atmosphere of Uranus. They knew that if Uranus had no atmosphere, it would cut the light off of the star in a very sharp fashion, just like a knife cutting across that light beam, and the light would suddenly drop as Uranus passed in front of the star. Instead of seeing the brightness of Uranus and the brightness of the star, Uranus would pass in front of the star. We'd only see the planet Uranus, and it would block the light of the star. Now, what actually happened was something that looked like this. So imagine we're looking at the brightness of this star, and we see it coming along, and all of a sudden what happened was a drop of a brightness that looked like that, and then another one occurred, something like that, and then eventually Uranus came along and blocked the light of the star like this, and after Uranus had passed, the brightness of the star resumed, and then we saw another dip that looked like that, and another dip that looked like this. Okay, it was these dips that were exactly symmetrical on either side of Uranus that were a surprise to astronomers. In fact, they wouldn't have seen them if the instrumentation had not been turned on about 40 minutes before the occultation was scheduled to take place. So what had happened? What caused these dips? Well, we know that there are rings around the planet Uranus. There's one of them, and just imagine another one that looks something like that. And so as Uranus moved across, the rings blocked the light beam first. The star was dimmed a little bit by the first ring that caused this dip, and then the second ring reached the light beam, and this dip occurred. I haven't drawn it, but altogether there were nine different strings or rings that blocked the light. It wasn't seen at first. It took a while to discover that, but we now know that there were something like 9 of those orbiting Uranus, 9 of those rings that orbited the planet and caused this.